All right, calculus, we're looking at AB 43 part 2. So let's just jump right into it. First of all, number 10, I'm going to kind of ignore it just for a second because I put it up on the next slide. We'll work with it there. Let's just focus on number 9. So I look at this, and not only am I given an equation with dx dt, blah, 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 all this kind of stuff, but I'm also given some information here. And anytime you're given a condition where it tells you some values, this is going to lead you to solve for the constant of integration. So let's do that. Let's figure out the integral and have a constant in it and solve for that constant. So a couple of things. First of all, I see x's and t's in here. And this thing where it says x of 0 equals 1, so that's like a function like x of t equals a bunch of stuff. And when I plug in t equals 0 over here, I'm going to get that x equals 1 with all this other stuff. Okay, so that's useful information. T equals 0, x equals 1. And now let's work our way through all these pieces. So I have x e to the negative t dx dt equals 1. So first, let's take care of this e to the negative t. That's like saying x over e to the t, because a negative exponent just means, across the dividing bar, times dx dt equals 1. This actually winds up being easier than you would think, because if I'm trying to separate the x's and t's here, I can multiply both sides by e to the t dt and move both of them over to the right side. So I would have x dx on the left side, and on the right side I would have e to the t and dt, which those really are very easy to deal with. So let's just jump right into them. So I'm going to take the integral of both sides here. On the left side, the integral of x to the first power becomes x squared over 2, no problem there, equals on the other side, I have the integral of e to the t dt is just e to the t. That was a piece of cake. So I take the integral, but now I have this plus c. So I need to deal with this plus c. I have plus c. Let's write that in gray. It's not dealt with yet. So I have plus c. I got to work that out. Now this plus c could be on either side. It really doesn't matter. But now I got to use my information from right here. So t equals 0, x equals 1. I'm going to plug that in down there, and let's see what happens. So I have x squared over 2 equals e to the t plus c. But x is 1, so that's 1/2. E to the 0 is just, well, that's 1, so that's going to be easy to deal with too, equals plus c. So how are we going to get this? Well, if I work it out from here, I guess what we could do is say e to the 0 is 1. Here's 1/2. And if I subtract 1 from each side, that's like subtracting 2 over 2 from the other side. Then I have negative 1/2 equals c. All right, so we have negative 1/2 equals c. Now I'm going to take that and plug it in here. So that would give me x squared over 2 equals e to the t minus 1/2. And you might think, okay, that's not a big deal. But actually, as it is now we got to kind of get x by itself. So I got to multiply both sides of this equation by 2 times 2. That'll give me x squared equals 2e to the t. And then over here I'll have minus 1. Then I got to square root both sides, get rid of that squared. So x equals square root 2e to the t minus 1. There we go. We figured it out. Notice there is no more constant c. We solved for it and plugged it in. This is now all in terms of x and t and numerical values. Now this might be written slightly different. You guys could write this as x of t, like that, equals square root 2e to the t minus 1. That could work, but you don't have to. So either one of these would be fine. Let's do number 10 now. Same idea, same prompt, different word. So we have dy dx, and we got 1 plus x and xy. All right, so there's a couple things going on down here. It's hard to see how we would separate this. We know that y of 1 equals negative 4. That's like saying x equals 1, y equals negative 4. So that's going to be useful later. Over here, though, let's see what I could do. Well, if I multiply both sides by dx, because I do have to do that just to at least get rid of it down here in the denominator, because that doesn't help me, then I'd have dy equals 1 plus x dx over x times y. Now I could multiply both sides by this y. Let's do that. So multiply by y on both sides. And that would give me y dy is equal to 1 plus x over x all times dx. Alright, not too bad. So now we're ready. We have y's with dy's, x's with dx's, and we are ready to integrate. Okay, there's a couple of things here. I see kind of a complex fraction, and it'd be so much easier if I could split this up into multiple fractions, which I can do. So when I do this integral here, I'm going to consider this like 1 over x dx and x over x dx. And I'm going to integrate those separately. And then this integral of y dy, we'll deal with that as well. So the first one, 1 over x dx, what's that? Well, that's natural log of x. And this is really 1 over 1. And the integral of 1 is just x. Then on the right side, we have y to the first power, which is going to become y squared over 2. And then, of course, we have this plus c. All right, so where are we at now? We have x is 1, y is negative 4. That means that I'm going to have negative 4 squared divided by 2 equals natural log of 1 plus 1 plus c. Let's simplify this. Well, negative 4 squared, that's 16. So we got 16 over 2 equals natural log of 1, that's 0. And then we got 1 and c. Keep going, we got 8 equals 0 plus 1. It's going to be 1. And then plus c. There we go. Okay, we're getting there. We subtract 1, subtract 1. And we have 7 equals c. All right, that's good so far. We have x squared over 2 equals natural log of x. Oh, pardon me, that's not x squared over 2. What are we doing here? The inverse where we switch x and y? No, we're doing regular. Y squared over 2 is natural log of x plus x plus, what's c? It is 7. Now from here, okay, so let's get y by itself. Why would we want to do that? Because we want y equals something. That's what we want. So I got to multiply both sides by 2 all the way around. That'll give me y squared is equal to 2 natural log of x plus 2x plus 14. All right, let's keep going with this. That means now I'm going to square root both of these. That'll give me y equals square root of 2 natural log of x plus 2x plus 14. Square rooted to the 1/2 power. Same difference. Check, done. Okay, so what did we do? What was kind of the summary of our process there? So first, we separated. Then we integrated. Then we substituted with the given stuff, the numbers. Then we solve for c, and then rewrite. That's what we basically did there. Okay, so let's do it again and again, 2 more times. And then we'll be done. So dy dx equals y squared plus 1. Y of 1 equals 0. What does that really mean? That means that x equals 1, y equals 0. Okay, I can do that. Let's do it. Now, what do we need to do? Well, I see that I have dy and dx, so let's multiply by dx on both sides, times dx times dx. That'll give me dy equals y squared plus 1 times dx. All right, now this might not seem like a big deal. You know, you got y squared plus 1 and dy. And to work from here, I need to move these y squared plus 1 over to the other side. So let's do that. Divide by it on both sides. And we have dy over y squared plus 1 equals dx. dy over y squared plus 1 equals dx. At this point, I can integrate. I'm going to integrate both sides. Now, it's not necessarily obvious what we got here, but y squared plus 1, that's like the same thing as 1 plus y squared, which really makes this look like tangent inverse. So it's going to be tangent inverse of y. It's really y over 1, and out front we'd have a 1 over 1. But tangent inverse of y equals, then what do we got over on this side? Well, the antiderivative of 1 dx is just x. So x equals tangent inverse of y. Now, here's where this is almost crazier than you would even think. Because you would say, ah, that looks complicated. Well, that's actually the same thing as saying y equals tangent tangent of x. Wow, check that out. Okay, so y equals tangent of x. Oh, wait a second, what are we missing here? We are missing a plus c. You know what? Let's go ahead and put a plus c in here. And we're going to plug in the values properly from there, just so we don't cheat on anything. Because we forgot to figure out plus c without doing some other math here to simplify that. So y equals 0, so I need to have tangent inverse of 0 equals 1 plus c. So when does tangent inverse of 0 even happen? Well, tangent inverse of 0 is actually, when does tangent equal 0? That's really the question. Tangent of what equals 0? Well, that's when sine equals 0, and that happens at 0. Tangent of 0 equals 0. So this is going to be 0 on the left side. And on the right side, we have 1 plus c. Subtract 1 from both sides. Negative 1 equals c. So now let's rewrite this. That would give me tangent inverse of y equals x minus 1. Now if I were to reverse this, kind of take the tangent of both sides, so tangent of this side, tangent of this side, that's going to give me y equals tangent of x minus 1. There we go. All right. So what's going on here? Now this is slightly odd because we got something times something times something equals 0. But then we have this extra x here. And what should we do with that? Well, because we have to have the x's and y's kind of being multiplied or equal on separate sides of the equation, I am going to multiply this or add, really subtract, this x over to the other side. That would give me 2y times radical x squared plus 1 times dy dx equals negative x. From this point, I can multiply by dx on both sides, and I have negative x dx on the right. And now I have this 2y and the dy, but I need to get rid of this x squared plus 1. So I'm going to divide by x squared plus 1 on both sides. Move that over as well. All right, we are almost there. We're really close. So I would have 2y dy equals negative x over radical x squared plus 1 dx. So now you're probably racking your brain, okay, whoops, what do we do now? Well, we got to integrate both sides. And left side, not big a deal at all. So it's just y squared, and that's it. Equals. Now how do we deal with this over here? Well, I see that I have x squared plus 1, and I know that if I were to take the derivative of that, that would equal my numerator. So this looks something like, kind of like a square root of u and a du. Like 1 over square root of u and a du. Well, I need to do some substitution to really figure out how those pieces balance, because I have a feeling there's going to be some constants in there too. In this case, we have a chain. You know, we got this inside piece here, the x squared plus 1, so that would be our u. And then we also see that I need to do the derivative, so if I do du dx, I'm going to get 2x, and then let's put a dx over on that side. I have the x dx, but this says negative, so I need to first divide by 2, or multiply by a half, and I'll have 1/2 du equals x dx. However, this x is a negative, so I'm going to put a negative there and a negative 1/2 here, so I could balance that negative as well. That'll give me in the end, need some more room here. That'll give me in the end. So now I need to integrate negative 1/2 1 over square root of u du. And of course, on the other side, we got the y squared. Let's go ahead and put the plus c over here. Doesn't really matter where we put it as long as we know where we did put it. We put it over on the left side. Okay, so I'm not quite done. I need to do the antiderivative of this. So the negative 1/2, that's a constant. That's just going to move over. U as a square root in a denominator is like u to the negative 1/2 power. So now I got to do the power rule for that. U to the negative 1/2 du. Well, I add 1 to that power. I'm going to get u to the 1/2 over 1/2. So now I have y squared plus c equals negative 1/2 u to the 1/2 over 1/2. Let's do some simplifying here. This 1/2 and this 1/2 would cancel each other. They'd simplify. We'd have y squared plus c equals u to the 1/2. Wait, what's u? That's x squared plus 1. So x squared plus 1 all to the 1/2. So we are nearly done here. We just got one minor detail. It says y of 0 equals 1. That means that y equals 1 and x equals 0. Because we plugged in x equals 0 and we got out y equals 1. So y is going to be 1, so that's 1 squared plus c equals, over here, x equals 0. So that's 0 squared plus 1 and then square root of that. The 1/2 power, that's what this is. Okay, so I got 1 squared, or 1 plus c equals 1. Well, check this out. Subtract 1 from both sides. What's c equal? C equals 0! The constant is 0. Alright, so that's going to jump me all the way back to here. C equals 0. So now I'm going to rewrite this, or actually not even there. Let's say right here. C equals 0. Let's see what we would have. Or let's keep going. Here, y squared plus c equals all this stuff, but c equals 0. So y squared plus 0 equals square root of x squared plus 1, because that's in here, and the square root is because of 1/2 power. So y squared equals square root of x squared plus 1. Now this is where people kind of go crazy, because, so I'm going to square root both sides. And then I'd have y equals the square root of x squared plus 1. And then somebody's like, whoa, square root of square root. Well, let's write that in fractional powers. Maybe that'll be a little bit easier to comprehend there. So instead of square root, I'm going to say 1/2 to the 1/2. Ah, now this actually makes a little more sense. That means that y really equals x squared plus 1 to the 1/4. is you would multiply those powers. Whenever you have power to a power, you multiply the powers. There we go. Final answer. Remember, ask questions as you need, but again, mostly just watch the video a second time. Maybe you can see the steps a little more clearly when you kind of have an idea where they're going. All right, so that's it for part 2, and we will see you in video number 44.